Number 3 says to use a math drawing and our definition of multiplication to explain why 3 times 6 equals 6 times 3 without computing that both products are 18, and just use the idea of saying the same thing in 2 ways. So I think there's other ways that you could do this, but I'm going to stick with an array. I think that's a really easy way to do this. So you could possibly, show 3 times 6 and 6 times 3, like with number lines or with fraction strips. I'm just gonna stick with the array though. So you could draw, like, you want to do stars again, you could do stars, draw dots, whatever you want to do. I'm just gonna draw a grid, and just do it that way. So I'm gonna draw a 3 by 6 grid, which basically just means I'm using squares, right? So you could use dots, stars, whatever symbol you like to use. I'm just using squares essentially. But any array would work. And so like this might be like a 3-foot rug by 6-foot rug, right? And so we break this into square feet and then rotate it and see the same. Again, I'm going to write that in terms of an equation. So like I could say this is 3 rows times 6 square feet per row. And so that would give me the total number of square feet, because that's a fast way to calculate the total number of squares, is just to multiply, right? And then if you rotate it or view it in terms of columns, we could also say that that's 6 columns times 3 square feet per column. And that again would give you the total number of square feet, or the total number of squares in that array, or if you use stars or dots or whatever you used. So then number 4 is saying if A and B are counting numbers, why must A times B necessarily be equal to B times A? How do we know this if we, even if we don't know what the products of A times B and B times A are? And so like you could probably answer this lots of different ways, but that's essentially what we just did, right? We didn't actually ever calculate 3 times 6 was 18. So like you can do that. This is just saying in general, how can you do that? So I'm just kind of describing here what we did. So, and there's other ways to do it, but we can always draw an array. It's a really nice visual way to demonstrate the commutative property, because like I said, all it takes is just rotate it. So A times B, and this works, by the way, even if they're fractions or decimals, right? So even though we're not doing fractions or decimals yet in MAE 201, this would work for that as well. So that would describe basically we can rotate, but since I'm not able to rotate my screen, I'll say describe it in terms of rows and then describe it in terms of columns, right? So describe that product as both rows of objects and columns of objects. So for any numbers, right? Not just 3 times 6. So we could say any number A times any number B. That would be like A rows and B objects in each row, versus if I describe it in terms of columns, then it's B columns and A objects in each column.